All right, for this lesson, we are going to be talking about direct variations. So if you look on page 211, you'll see that we have definitions of what direct variation is. And the definition is a linear relationship between two variables and is written in the format y equals kx or y or k equals y over x, and k does not equal 0. So k is any real number that does not equal 0. And when you find an equation like this, y equals kx or k equals y over x, that is a direct variation. So this is going to be a linear relationship between two variables that is written in y equals kx. Now this should look fairly familiar, this formula right here, because y equals kx is our slope formula, is our line formula for a line that goes through point 0, 0 and has a slope. So like this would be our slope, and then you'd have x and y. Okay, to check whether an equation represents a direct variation, solve for y. If the equation can be written as y equals kx, then it represents a direct variation. So the first problem they give us in identifying is 2y equals x. So we want to solve for y. So we're going to divide each side by 2, which is going to give us y equals 1/2 x. So k is 1/2, and that is a similar formula. Therefore, this is a direct variation. The equation is in the form y equals kx, so the original equation is a direct variation. The constant of our variation is 1/2. The constant of variation is k. Constant of variation, also known as our slope. This is the same thing as our slope. Okay, let's try another equation to see if it has direct variation. So we have y plus 1 equals 2x. So to solve for y, what do? Well, we subtract 1 from each side, which gives us y equals 2x minus 1. Now, our original equation is y kx. So we're going to write this up here. And then leave it so we can look at it. Does this equation look like this equation? The answer is no. And the reason this does not look like this is because of that -1 on the end. So this is not a direct variation. Okay? This does not look like this because it has that. Okay, so let's turn the page. And it says the equation y equals kx can be solved for the constant of variation k equals y over x. If y over x is the same for all ordered pairs in a set of data, then the data set represents a direct variation. Okay, so we're looking to see if we have a constant rate of change within our data. And to write a direct variation equation for a set of data, substitute the values of y and x for k in y equals kx. So we're going to take this equation, we're going to write it like this. Oops. And then we have a table. It says, tell whether each set of data represents a direct variation. If it does, identify the constant of variation, and then write the direct variation equation. So they want you to find k. So we have weight, and then we have price, and we have these boxes, and we have 1 over 3, we have 2 over 6, and we have 3 over 9. So this is our y, this is our x, and we want to know, is this a direct variation? This is only a direct variation if k, or our constant of variation, is the same for every step of the graph. So we'll try the first one. So y, which is 3, over x, which is 1, equals 3. Okay. Next one, we have 6 over 2 equals 3. 9 over 3 equals 3. So there's two parts to this question. The first part is this a representation of a direct variation? The answer is yes. Second part of the question is, what is the constant of variation, or k? Well, that is 3. So your answer is going to be yes, k equals 3. Okay, let's try the next one. The next one, they give us the constant speed and time. Okay, so time is our y, constant speed is our x, and we have 10 over 3, 20 over 1.5, and 30 over 1. So if we start off, we have 10 over 3, and then we have, oops, sorry, I read that wrong. 3 would be our y. 3 over 10, then our next is 1.5 over 20, which they multiplied by 2 so that you don't have a decimal up on top. So we're going to multiply that by 2, multiply that by 2, and that equals 3 over 40. And then the last one is 1 over 30. And if we look at these numbers, so we have 3 over 10, 3 over 40, and 1 over 30. Do we have a direct variation? Well, the answer is no, because these three numbers are all different. So they are not a constant of variation. They are not our change of rate, our slope, however you want to look at it, is not the same. Okay? It is not a direct variation. Now, the last way that we can identify a direct variation is with graphs. So, the last example, they say say, identify a direct variation from a graph. Tell whether each graph represents a direct variation. Okay, if it does, identify the constant of variation and then write the direct variation equation. So you have 3 answers if the answer is yes. 1 if the answer is no. So the first graph that they give us looks something like this. And we have a point plotted there, and there, and there. Okay, and then our second graph is similar. Except our points are slightly different. So our first point is here. And 1 on 1. Okay. So, the easiest way to know if our graph is a direct variation is whether or not it goes through 0, 0. If it goes through point 0, 0, it is a direct variation. If it does not go through point 0, 0, it is not a direct variation. So this one, the answer is no. But this one, the answer is yes. So that's the first part of the question. Then it says, identify the constant of variation. So that is your slope. Well, we can count the slope. It's rise over run. It goes up 2 over 1. So K is 2. Now you're going to write it in this formula, and that's Y equals 2x. So you have 3 answers when you're looking at a graph like this. Okay, do not forget to read your directions. If it asks you for 3 things, make sure you have all 3 things. Otherwise, the problem is wrong. Okay, the very last part it says is about an eastern box turtle. And they are giving you a formula that you're going to write. Then you're going to make a table. And then you're going to graph it. And then you're going to check to see if you did it correctly. So we're not going to go through that example because I feel like I've taken up enough of your time. So what you do need to do is if you have any questions, raise your hand and ask so that you know what you're doing. And if you don't have any questions, you can move ahead and start working on your assignment.